Let me discuss about the interfacing ADC. Here we need to understand how interrupts we are going to use, and also you can understand the timer we can use to generate the delay, and what is the importance of interrupts. So real time, how we are going to use that, we are going to understand by interfacing ADC. So ADC is one, it is going to convert analog to digital signal. The most of the physical the things not in digital form. So for example, we need to convert temperature, so that you can convert into the can't convert directly into digital, we can convert it to analog, in turn is converted into digital to process further with the help of controller. If you want to process, we need to be data in digital form. So for that, we need an analog to digital converter. Similarly, if we need to drive any actuators, we need the data in analog form. In that case, we require a digital to analog converter DAC. So these two are very, very important devices. So let us here, we are taking the example of ADC interfacing. For interfacing, what are the steps we need to follow and how we are going to interface, how we are going to convert this analog signal to digital. So while converting, how we are going to use an interrupt. This concept we are going to understand in this case. So let us see here, ADC we are going to interface to the 8051 microcontroller. With program we are going to discuss. See here, analog to digital conversion, we have to take the analog value. There is a for taking analog value, there is a time fixed. Means how much the interval. Here we set the interval as 50 microsecond. Is nothing but every 50 microsecond we are going to take the new value from analog and convert to digital. So for that we are going to use timer 0 to generate a 50 microsecond delay. Whenever 50 microsecond time is over, the timer is going to send a signal, that is an interrupt signal, to the controller, so that it will stop its function and take the new value from ADC and start the ADC. Once analog to digital conversion over, the analog to digital converter will send a signal to the controller. It means that conversion is completed. So with an interrupt signal, it is going to send the interrupt to the controller. So that once ADC send a signal to the controller, then controller stop its function and read the digital value. So this is a process to be followed. Let us see how it is be interfaced. See, look at here. This is a ADC, analog to digital converter. So analog is the input here we are giving, analog input, and here the interfacing signals are there. This interrupt will be generated by the ADC whenever conversion is going to complete, analog to digital conversion. Then we need to send, before start, we need to send the start of conversion to the ADC. This is using write signal. Then once completion is over, we need to send low read signal. Then we can able to read the data digital value. Okay, let me once again explain in brief. The analog input is applied here. So this ADC is going to convert to digital value. So first we have to tell start. We have to start the conversion. So once conversion is completed, this ADC will send an interrupt signal to the controller. This is an external interrupt here, int is 0. So once interrupt occur, the controller stop its function. It means that ADC is having a data in digital form. Then to read this value, it required to send one read signal to the ADC. So this will send a read signal, then it will read this data. So the data is available at port 2, and once again it will send to port P1. So port P1 in turn is connected to DAC output, and this both will get a same, because whatever analog input converted with ADC, and once again If you convert back to analog means it will be both will be same. So now let us see here. So ORG main program is going to start here. SGEM main, instead of starting beginning, we have to start from here. So here few locations are for, this is for external interrupt 0. Whenever external interrupt 0 occur, come to this location and it will go and execute this ISR for external interrupt ISR. Then whenever timer 0 interrupt occur, it will come to this location. This is a vector location 00B for the timer 0. Then it is going to execute the ISR, timer 0 ISR. So as I told you, the timer 0 ISR for every 50 microsecond, the interrupt is going to occur. Here, whenever this for external interrupt, whenever the ADC conversion completes, it will send a signal to the control. This is external interrupt. Now let us see. So set external interrupt it's activated. You have to configure decon register and also enable the external interrupt in enable interrupt. Okay, then enable DAC also we are using. So just you have to enable that one. Then you have to set the timer 0 in 8-bit auto reload mode to generate the 50 microsecond delay and load the corresponding value into the register. Then here minus 50 is nothing but it will be subtracted from the highest value with 50 and so that will be the starting value. So after 50 times the overflow is going to occur. Start the timer 0, start timer 0 and enable timer 0 interrupt. You have to enable timer 0 interrupt also. Then there is a global enable to enable any interrupt. This global enable bit should be 1. Then SGEM infinite. Here will hold here only the pointer. So this all initialization will be done. Start the timer, start the interrupt, all enable the interrupt. Whenever 50 microsecond delay generated by the timer 0, then interrupt is going to generate. See, whenever that 50 microsecond time delay over, then timer 0 interrupt will be generated. When timer 0 interrupt is going to execute this timer 0 ISR. Whenever timer 0 occur, it will come to here. Timer 0 has jumped to timer 0 ISR. It will come to here, timer 0 ISR. Here, it has to take the new value, analog input for the ADC and start conversion. That is clear P3.6 means ADC right line, low and high signal. If you send on this right line, then it will start conversion. Then return from interrupt, return to main program. Once again is over here. Started the conversion, analog to digital. So whenever it completes, whenever analog to digital conversion completes, it will send a signal external interrupt. So whenever external interrupt occur, it will come to here 003 memory location. Here it will be return jump external 0 ISR. It goes to this ISR interrupt service routine. Here, once conversion completed, it has to read the data, the digital data. For that, it has to send the read signal as low, P3.7 as the read signal here. Read signal P3.7 the read signal it has to send low. So it will send as low, then read that port 2, the digital data is connected to the port 2 of the controller and in turn sent to the port P1 and then it will make it as high. So only one time it will read and make it high so that whenever next time it require, whenever at the time of reading, it will make it low and read it. So then return from the interrupt. RTI come to hold here. So it is going to repeat whenever 50 microsecond is delay generated or then it will read the new value, analog value. Then ADC will be start. After conversion, ADC will send an interrupt signal. Then processor will stop its function and send the read signal and read the digital value. This will be continuously going to perform.